Hello, I'm Hall Robbins, and I'll be graduating at the end of this summer.
My name is Andrew Braisted, and I will be graduating this December.
And my name is Jesse Cooper, and I will be graduating this summer.
Tennessee Technological University has been working on a directed energy deposition additive manufacturing process, more specifically WAM or wire arc additive manufacturing. Our main objective for this project is to use software to create a hybrid manufacturing process that is completely automated. All of the 3D testing and modeling will be done in a new software from Autodesk called PowerMill. This software will allow us to simulate the WAM process as well as the machining process. This will show both the additive manufacturing process and the subtractive manufacturing process. Through this technique, we hope to create a simple impeller that will be completely made from CAM toolpaths from the Fanuc robot and the Fadal CNC machine.
This is basically the goal of what our project was. Dr. Kim created this out of paper, obviously, and this was just to show basically what the WAM hybrid manufacturing process is capable of. So as you can see, there's curved parts here along with a substrate that those will be deposited onto. So this is what we started with. And then we created a model based off of this, loosely based off of this. So yeah.
So to get a more solid model off of Dr. Kim's paper model, we made a 3D model on AutoCAD and created a 3D model through our rapid prototyping center here at Tech. So we looked at Dr. Kim's previous research to determine the thickness of the weld beads and possible defects such as cracking, and we wanted to look and try and find the best consistency of the material for a clean finish and a better final product.
So for all of our modeling, we used Fusion 360. It just had the best CAD and CAM software that we've used recently and gave us the easiest way to take our 3D model to the CNC machine. Our 3D printed model, we were able to get the size of the substrate that we needed. From our substrate, we had to machine an arbor that would hold this into our lathe because our lathe truck wasn't big enough to hold a 12-inch piece of substrate.
So we needed to machine the substrate down to get an accurate measurement to print on, and to do that we needed to turn it in the lathe, and the 12-inch diameter is too large for the lathe. So we made an arbor, and for that arbor we needed to drill a hole in the substrate to have a press fit on it, and we drilled a hole into the arbor so we could thread it and have a bolt to go into it to hold it snug in the lathe.
Once our substrate was machined, we gave it to Dr. So and Yixing, and they did our deposition for us.
So we used our 3D model and we got the center of all of the fan blades, and they used that, they clamped this in place on this table and went and poked down on those points to create the model in the software that they've got hooked up to the robot right now. And then they used those points to create the paths that they would follow. So yeah, it's basically we just have the Fanuc robot hooked up to a welder that they control, and hopefully in the future this will all be more automated and we won't have to plug off of points. We can put in G-code just like we do in the CNC, but right now we don't have the capability to do that with what we've got here. So this was a pretty good alternative, and it came out with a pretty good product as well.
They touched off with just touching the robot to the points. Our final substrate deposition wasn't exactly completely accurate, which caused some problems with going to the CNC without a 3D scanner.
So our solution to that problem was, instead of doing the entire thing as a better proof of concept, we just pulled out one fan blade. So we still have curves, so it's still a complex machining operation. And so we created this in AutoCAD, 3D printed it, took some measurements off of it. They did the same process, but now that it's only one fan blade, we were able to feel a lot better about it, do it a lot safer, and go in and measure it exactly to see where all those points are that they touched off on. So this was our first try. This is from a solid block that we CNC machined down. And then this was the deposition. As you can see, we tried a couple things. So we cut off from the top to see how good of a surface finish it would do on the bottom of an end mill. And then we also cut off on one side so that you can see better the transition from the welded deposition to what the surface finish. And this is a very nice surface finish, which also gets good dimensional accuracy at the end, as well as removing stress concentrators from all of the waviness in the weld beads. So yeah. So this is the CNC we used. It's a Fadal CNC. So basically we took our deposited part, took the outside width measurements of it and created a stock model. So a stock model is basically what we start with to do our programming, where our machine is going to start, and then we create tool paths that will go in and cut it out. So it just sits in the vise right here, and it, as the tool comes down, machines it away as the coolant cools it and lubricates it.
And to kind of conclude what we've completed in our project so far and wrap up this presentation, we were able to accomplish a similar end goal to what we were planning on, even after running into quite a few problems, such as the complexity and lack of support for a program like PowerMill. We were able to do everything in Fusion, and because of how they did the actual deposition, which was touching off the physical points and using offsets, this made it to where the fins on the substrate weren't exactly in the same location of our model. Because of this, we switched to the single curved fin, which was still enough to accomplish what Dr. Kim was looking for, which was the machinability of a complex AM structure. In the future, something like this will be a lot easier because of the 3D scanner that they have on order, which I believe will be here probably in the next month or so. This will eliminate the need to reverse engineer these structures, like taking measurements of every physical point that you can to make a model similar to this. So the 3D scanner, along with the new robots that are able to actually communicate with the welder and a program like PowerMill, will make this process much easier to do.